In this video, we're going to talk about a new kind of list for us, a doubly linked list. And the next homework assignment is going to be based on creating this. So there's a version in the book, but the version in the book is typed and it's complicated, kind of like the linked list. So what I want us to do this time, I want us to create our own simplified version of a doubly linked list. So let's just talk about this idea of a doubly linked list and what we're going to create in ours. Then I'll show you the assignment and then we'll go and start some code. So a doubly linked list looks like our regular linked list, except we have two fields here in the bottom. One is going to be for a next, which works like the link worked before. The other one, though, is going to be a previous, okay, which is going to take you back. Okay. So unlike the other linked lists that we did, we're going to be able to move forwards and backwards through this list. Okay. So this will simplify some operations. At some cost, we have to store these extra um, pointers, but it shouldn't be massive. Okay. So that's the basic idea. So let's go ahead and take a look at the assignment itself, and I will be releasing that here in a minute. Okay. I know it's a little early to release an assignment. There's no in class on Monday. We'll be working on this. Okay. So this is the programming assignment for us. And again, we're doing just a doubly linked list of integers, so nothing else. So we don't have to do no templating at all, which should make life easier. Okay. So this doubly linked list, we're going to go and do some of this stuff that as we've done in the past. Okay. So we're going to start with our node structure. I'm going to call it node type like we have before, but it's going to have two pointers instead of one. So we still have our int for data. We may have used info before. They're interchangeable. As long as you're consistent, doesn't matter what you call it. Okay. But this is going to have the next pointer, which is a pointer to a node, and then also the previous pointer, which points to the previous node. Okay. As far as this um, class goes, it's going to have to have an instructor, which will initialize an empty list. Okay. Have to have a destructor that's going to allow us to get rid of all of the nodes that we've allocated. Okay. We have an insert front, an insert back. Okay. Have a delete value, which allows us to go through and find something. Okay. Note that we don't have a search function, so this delete's going to have to actually go through with a current pointer and then delete the area that we're there. Okay. And a print forward, which would be using the next links, and then we can do a print backwards doing the previous links. Okay, starting from tail. Okay. So again, we're going to have these two pointers, the node type pointers for head and for tail. Okay. And then our main program is just going to do some basic things like this. And here's what your output could look like. Okay. So let's take a look again at the picture here so we have a little idea of what we're talking about. Okay, and then we can get started on the coding. Okay, so again, here's where we're headed. Okay, the constructor should be pretty basic. We can think about if we have an empty list. So if I wanted to add 5 to an empty list. So if it's an empty list, and we can tell it's an empty list because head's going to be equal to null, the null pointer. Tail should also point to null. Okay, we're going to create a new node. And then once we create the new node, both the head and the tail will point to this new node that we've created. Okay. And then both the next and previous would just be point to null. Okay. A little different if we're adding to the front. So this was an add front. Okay. An add back would look exactly the same for this case. But now we're adding to the front where we have an existing list. Okay. So we create the new node here. And again, having these pictures are going to help us. Okay. So new node's going to point to here. That'll be the pointer to this node. Okay. So to make this be at the front, we're going to take the head. Gonna let me do that. That may be all grouped. That's really, oh, I got to edit this way. There we go. So I can basically take the head and I want to move it to here. Okay. Of course, before I do that, okay, if I would have done that in the code right away, I would have lost the rest of the list. Okay, so we start with making sure that the next pointer of our new node has to point to the old head. We move the head, and that should be it. Okay. We should be good in either case. Okay. One other thing. We have to make sure that we change this previous node here that was null. It has to go back to this new node. Okay. And now we've added that. That's kind of the schematic of what we're doing. Okay. Okay. So let's look at some actual code here to get us started. And again, you can copy this code if you like. No issues there. Okay. I want a little bit bigger, maybe. So I'm calling this doubly linked list.h. Okay. I went ahead and started. We're including IO stream and we're using namespace standard to get us going. Okay. The first thing we have to have here is our struct with a node type. Okay. Again, no templating necessary on this one. We're going to have an int for our data or info, whichever one you want. I'm going to have my node type star. No, wrong place for that. For next, which points to the next item, and then our node type star previous. Okay. That should take care of our struct for us. Okay. I can now start it with my class doubly linked list. Okay, it's going to start there. I'm going to go ahead and put in the end so I don't forget it. Okay, and then we have our public section. Okay, and then we have our private section. And again, you can copy this code 100% to get you started. And let's get some of the things done. Okay, so in the public section, I'm going to put my function prototypes here. Okay, but first, but instead of a prototype, I'm actually going to go ahead and just put in the constructor directly. Okay, so let's do that one first. So I'm going to do a doubly, let me find the home keys, doubly linked list, my constructor, my default constructor. Okay. When I create a new linked list, all I have to worry about, and I guess I need to have this private down here so we can see what we're doing. So I have my node type pointer called head and my node type pointer called tail. Okay. So then in here in my constructor, when I create a new empty list, then head is going to be equal to the null pointer, or you could use the word null in caps, doesn't matter. The book tends to go with null pointer. Same thing. Okay. So that's all my constructor needs to do, right? Set up those two things and we should be good. Okay. Um, so I should now theoretically be able to compile this. Okay. Doesn't like something. Oh, I didn't spell struct correctly. Left off the T. I didn't type it correctly. Struct. Okay. See if that's better. Okay. Yeah, that's really interesting what it doesn't like here. I think it's okay unless I've typed it incorrectly. Let me check that again. Yeah, I think it's because there's not enough stuff there. So I don't, again, it's a constructor, so it doesn't have any type. Okay, it should be called, oh, that's the issue. I misspelled that. Let's try that. Yeah, we're good now. Okay. Whenever you um, compile a .h file, you want to do a remove star GCH. Those are really big files that it creates that we can get rid of. Okay. You don't have to do that, but I always like to do that. Okay. So that part's okay. So now we should be able to go ahead and I'm trying to get to a minimum set of things that we can run a test program with. Okay. So I'm going to go ahead and also do an insert front. Okay. So in the public section, I'm going to go ahead and here and have my function prototypes. Okay. And the first one of these, void function called insert front, which is going to take an int value. Okay. Should be all I need for that. And I can go ahead and copy that. And then down here, I have my function definitions for the doubly linked list. Okay. I can copy this down. I hit the right keys. Okay. But remember, after the void, I have to put it in the proper namespace. So I have to say doubly linked list colon colon. Okay. I don't need the angle bracket type because I'm not making this typed. They're all integers. Okay. But remember, since it's an actual function, I'm going to have that instead of the semicolon. Okay. So for this, we have some steps we're going to have to do no matter what. Okay. So we're going to create a new node. Okay. We're going to add it to the list, which is going to give us two cases. The add if list is empty and the add if list is not empty. Okay. Should really be the only two cases we have to worry about. Okay. So we're going to start by creating our new node. Okay. So we're going to have our node type star for new node. Okay. Going to go ahead and allocate it some memory at the same time. It's equal to new node type. Okay. So now new node is a pointer to a node type, and we've given it some memory. So it's sitting out there in memory somewhere. Okay. And for this new node, I want to set up its initial value. So value is coming in. Okay. So I'm going to make sure that my new node, I have to use arrows since it's a pointer. Okay. The data is equal to the value we're sending in. Okay. And then my two pointers currently don't point to anything. So the new node next is going to be equal to the null pointer. And my new node previous is also equal to the null pointer. Okay. So that sets up that node. Now we have to add it to the list. Okay. So we have two different things to do here, whether it's empty or not. So to determine if it's empty, I can say if head is equal to the null pointer. Okay. If so, I know the list is empty. And what that means practically is that head and tail um, need to both point to our new node. Okay. So I'm going to go ahead and set the tail here. The head is going to point to the new node in both cases. So the only the tail is different here. So I'm going to let the tail now be equal to this new node as well. Okay, we had an empty list. Now we have the head. We're going to set the head in a minute, but we have the tail for right now pointing to the new node. Okay. Else, so if we hit the else here, we know that the list is not empty. Okay. And the thing we have to worry about here, all of the next will be okay, the tail will be okay. It's already there. But we have that head previous has to point back to the new now the new node. Okay. So my head, this is still the existing head. I haven't moved head yet. Okay. It's important you don't move the head or you lose your head. Okay. The head previous is going to point to the new node. It's going to be the new head in a minute. Okay. And then in either case, okay, I can go ahead, put this down a little bit so you can see it. In either case, I can go ahead and set the head now equal to the new node. Okay. So I don't need these comments anymore because I'm kind of doing it in a different way. Okay. So if it's empty, then I'm going to set the head equal to the new node down here in either case. Okay. But for right now, I'm just going to set the tail equals the new node, and that's it. Okay. If the head is not empty, again, I've got that additional issue of setting the head previous has to point back to the new node, which is going to become the new head right here. Okay. So that should take care of that. Okay. And it sometimes can be helpful here. Let's say this is going to end the doubly linked list class. Okay. And this is usually easier to see, but this is going to end the struct. Got all my formatting okay. Okay, looks like it's okay. Okay. And then you can keep track of these if you want as well. This is going to end insert front. Okay. Now, insert back is going to be similar. The insert back, if the list is empty, is going to be exactly what we have. The insert back, if we're not, we're going to have to go from the tail and set the tail next and all that stuff. Okay, but I will leave that for the homework. Okay, so let's see if we've got this correctly. So let me go ahead. I'm going to compile it. It seems okay. I'm going to go ahead and remove that. Okay, and now I've gone ahead and made a test program here. Pretty basic. So for the test, I'm including the IO stream and I'm including the doubly link list.h. That's the header file I just created. It doesn't do much yet. Okay. So all I'm doing, I'm creating a doubly link list called LST, and then I'm inserting a 5 to the front. So, and that's all I have. So that's all I can do. Okay. If I run this and compile it, does that. I run it, doesn't do anything. But that's kind of what we wanted, right? It shouldn't do anything because we didn't tell it to do anything. But it's not giving us an error. Okay. One thing I'm not doing yet, my program has a memory leak. I'm not getting rid of the link list. I don't have my destructor set yet. So that's a problem. But for testing purposes, that's going to be okay. Okay. Again, a memory leak is going to be an issue typically when you have a program that runs for a long time. And these are still test versions. Okay. So once you get to that point in your code, then the next step really is to go on back to um, the program definition. And you can probably, if you like, add all of those right away. I mean, you can add those as comments. That's certainly something I probably would do, so I wouldn't have to keep looking back and forth. Okay. So at this point, I've got down to where the constructor is done. Okay, I don't have the destructor yet. Okay, which I'll need to do that. That's where you're going to go through with the temp node and set each of the nodes equal to that and delete them, go through. Okay. That'll be similar to what we do for the regular linked list. Insert front we've got done. Insert back will be different. The delete value, okay. Notice that's a Boolean, okay. So that's going to return true if the value was deleted. It's going to return false if it was not, okay, for whatever reason, okay. And that's going to have to search through until it finds it. Then we're going to have a print forward, which will start at head and keep following the next with a pointer until we're done, printing out the value each time. And then there's also a print backwards, which will start at tail, and it will use the previous to back through that. Okay. And then we have our head and tail there. Then our main program should do these things to be able to test. Okay. So hopefully this is going to give you a head start and some code to work on this. Okay. And I think this one is going to be due the 12th. I think that's on a Friday. Okay, at class time. Okay. So we've got other stuff. We've got homework due all over the place now. We're still working on the homework that was originally due on Friday, yesterday. This is Saturday that I'm doing this. Um, so we still have that homework where we're adding in those functions to our linked list. And then we have the problem set, which I think is due on Wednesday. I believe that's correct. You can check that, where we're using our linked list in programs. Okay. So again, what we're doing on this one, this is the tool creation and then the test of the tool. We're not using it for a program, but we will. Okay. So that's all I have got for this video. So if you have questions, make sure that you let me know.